Hello everyone, I'm back for IASP 321 Linux Administrators course. Today I'm going to give you a lecture and your midterm, as it was announced, will cover up to the slide that we covered today. Alright, so please make sure that you understand all the course materials and also textbook. The textbook, the midterm exam, according to the textbook, I believe that is up to the part 1 and part 2, which is up to chapter 13. Alright, that is approximately half of the course material that we cover in this class. A little bit more than half. Okay. Alright, so let's take a look some more here. In this module, I'm going to also briefly let you know if you need to install new software on your Ubuntu. Then this slide explains you how to. Of course, you need to have the privileges. If you install Ubuntu by yourself, and along the installation process, it asks you to enter login name and password. That login name and password has sudoers privilege, which is the privilege that you can install whatever the software that you can on your Ubuntu. Okay, so let's see. So what we need to do is to log in Ubuntu. There is a checkpoint, secure remote. So I'm going to right click on it. Currently it is connected, so I'm going to disconnect, and then I'm going to reconnect it. So in order to connect, then I can make sure that the site IP address and username is that, and password that I let you know earlier. So please refer to that, and then you can hear the message, connection succeeded. And after that, you need to find out the putty that you installed. So in this putty, choose silo one that you saved. If you didn't save it, then it should be 10.1.0.4. I'm sorry, that is not this 10.1.0.24 and port 2222 2222, and then open. Then you can see the login prompt. There, enter your login name and password. Let's see how many people are in. This is me. I entered a little bit of a few minutes ago, and this guy, I don't know if you guys logged in. Okay, so sudo apt get install fortune mod. Then it asks you to enter your password if you are in the sudo's list. So I can enter my password. And it is, well, I already installed. Therefore, if you do fortune, then you can see the fortune, like fortune cookie that you might read from many times from a Chinese restaurant, right? So there is a fortune. You can install not only that, many others. For example, if you want to install Python 3, version 3, then you can do also. Then it can be installed. All right. Okay. What else? Okay, the processes that we are going to learn today. What is a process? Process is nothing but a program that could be the software that you download, or program that could be the program that you created, for example, Java program or Python program, any language that you use to develop or implement on your own, then that is also, if anything, any program, if it is running on your process, on your computer, then it is called a process. So process is nothing but a program. But when a software program is running on the system, it is called a process. If it is not running, then we do not call it a process, although it is a software program. Okay? It is not launched. And another command that you can think is top will display an update task. Task is also a process, similar to process. And top is good to monitor processing in active, running, sleeping, stopped, zombie, etc. So top and jobs. Job also lists active jobs, active process. So, for example, if you say jobs, then currently there's no jobs. PS, process. Currently I have bash. This is my shell program is running, and right now this PS is just the PS that I entered, that I want to see, that I want to display the snapshot of current process. Okay, but if I want to see all the process, then there is a option called AUX. Then I can see all the process. Some of the process run and owned by root. Okay, so this gives you all of those. Tops. This PS AUX gives you the current. Current means when I issue this command, right at time, all the processes running is displayed in response to this command. So multiple columns, the process information in multiple columns, starting from user and process ID and percent CPU, percent memory, and so on and so forth. Okay, and the command, which command is actually executed. Command is again nothing but a program, okay, software program already developed by you or you installed. Okay, for example, this one was installed from the beginning. There are so many such things. SBIN, ISC, SID, and there are many others, right? Like bash, PSAUX. This is command that I add. So this gives you a list of current process. This gives you very useful information about processes. But only the problem with this PS is that this doesn't give you update as something changes. But if you run top, it gives you the current. Current means dynamically updated the information about process displays. Very similar to the ones that we've seen in the PSAUX command. This top command gives you more dynamic, real-time information, which is good, right? So this is also possible. And if you look at here, top, this is current time, and up 4 days, how long this the computer, this Linux operating system has been up and running. How long? For 4 days. There are currently 2 users. Load average is almost 0. Not much job is running. How many tasks? 134 tasks. Currently 1 running, 133 sleeping, and so on and so forth. Right? You can see the memory size is this. 2 gigabytes allocated to this Linux. Total currently 1 gig, 1.3 gig. No, that's free. Used only 93 kilobytes is being used. As you can see here, the Linux operating system is very, very efficient. Doesn't use much about the memory space. If you run this similar thing on Windows, then Windows maybe 10 times bigger the size needed. Okay, so this is very efficient. So I'm going to quit this by pressing Q for quit, and then BG, FG, kill all. Those are all the command that we will look at today. Okay, so let's look at a little bit of other command, other options. So we did this, right? And we did this also. So if you want to see PSX, then this gives you some of the process related U. Okay, if we want to see the command of the manual of a PS, then you can see the manual by typing man for manual and PS for process. So PS command is to report a snapshot of the current process, and there are options that you can see. So PS minus AUX is distinct from PS AUX. POSIX and Unix standard requires minus as an option. Print all the processes owned by a user named X, as well as print all the processes that would be selected by all process means A option. Okay. If the user named X does not exist, then this PS may interpret the command PSAUX instead of the print a warning. This behavior is intended to aid in transitioning all the script and habits. So you can read the manual. So you can see every process on the system using standard syntax, then PS-E-EF. To see every process on the system using BSD syntax. This is standard syntax. This is a Berkeley version. Or print a process tree, then PS AXJF. That is also useful. And so on and so forth. Okay. Alright. X logo is only on X Windows. Currently, we do not have X Windows, only the command line, so we cannot do that. If we do X logo, then X logo is currently not installed. You can install it by typing this command. You could do that, but what happens here is that whatever that requires for X Windows very nicely displayed on the console terminal, but none of us can access console terminal. We are remote, right? If we want to display X Windows remotely, then it is also possible, but ours should have X window running on our local. But I'm running on Windows, as you can see this monitor. Not X Windows, simply Microsoft Windows. So it's not compatible. So it's not going to. Okay. Background and foreground. PS gives you a list of process. If you want to run some process, some program, background, then you can do ampersand. If you want to bring it back to the foreground, then you can say FG for foreground and %, FG space and %, and number 1, number 2, number 3. This is a job number. Okay. So currently jobs, I do not have any jobs. But if I run, for example, Fortune gives me this, right? Your business will go through a period of considerable expansion, which is good. But if I want to run it as a background, then ampersand, like the Fortune space ampersand, that it runs background. Okay. And then right now I have another subdirectory, Python, and when I get there, I have a Python program. Okay, there's a Python program. If you want this Python, for those who knows the Python program, this program has the recursion. See here, def from here to there. This is a recursion. Why recursion? Because this is the function sum, but it internally it runs sum again, right? This is somehow sum, and another sum here. It calls itself inside. This is just print. Yeah, it calls. This is the function. That function in the body has a function called itself. Therefore, this is a recursion. Okay. Initially, it calls from for example, tail. Then this is end. Somewhere here it calls, right? Print sum. Yeah, this is the sum. It calls some number, but number is the user input. Okay, that is the Python. For example, if I do, I can run Python 3, and because that is local, so I can say local dot, and within local I have the program called the sum all for recursion. In chart, I made that, and if I run it, then it asks enter the number. So if I say number 7, then it gives me this. How can we get the sum of sum from number 1 to the number that is entered, right? So what it does is that it starts from sum 1, which is 1, right? And sum 2 is sum 1 plus 2, right? Sum 2 is sum 1 plus 2. So sum 3 is sum 2 plus 3. Sum 4 is sum 3 plus 4, and things like that. So if I do 7 from 1 to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, then I can simply think I can add 7 to the sum of 6, right? So this is a little bit of a pictorial explanation. But if I want to do this, I can run this as a background by simply pressing ampersand. Then it runs background. So if I do jobs, then let me see, I have only one job. The other one disappeared, right? It runs background. But if I want to do so it runs background. I can do something else, right? I can do PS AUX. All right. I can do jobs. Top. I can do top and quit, and also top, and I can put top into the background. That is also possible. So how many jobs that I have? So I can say jobs, then I have 2 jobs running background, right? They're all running background right now. My Python 3 runs background, top runs background. If I want to bring this top to foreground, then I can simply say foreground and number of that job. So I can say %2, then that top program. This program is the software package that we downloaded, right? We installed from the beginning. And % number 1 is the program that we created. But anyway, both or any one of these is, if it is running on our system, it is called the process, okay, and that is also a job. So I can bring it to foreground number 2. Watch what happens. Then top that command, we run it and immediately push it to background, right here, and I can bring it back to the foreground. Run, then failed to TTY, is it interrupted? Oh, there's the interrupted system course. So it doesn't go. Come back. So that is interrupted. I think some as the operating system's interruption issue. But I can bring this back. Okay, Python 3. So foreground and number 1, then I can bring it back. Okay, so what happens here is, oops, yeah, I didn't enter. It says enter the number, but I didn't enter. It is a multi-user processing. So somehow there's a job scheduling. So my job interrupted somehow. So Python 3, let me redo that, and then if I push it back to that, it enters, but it says enter on integer, but I didn't do. But it is pushed into a background job, so that I can see jobs, that I can see the background job, right? If I want to bring it to foreground, then %1, and it came to foreground, but immediately, because it already said here enter an integer, right here I can say number 10 or 5, for example. Then it runs automatically, right? Like this. That is foreground and background of the process. All right. And something, if I want to do, then we can kill the process. For example, I want to do this. Okay, so I don't do, but it is in jobs. But I want to kill the process. How can I kill it? So if I do PS, then I have a process ID here, right? 5122, that is a process ID for Python 3. If I want to kill the Python 3, then I can kill it. There's some options, some signals that you can use, that is on the page, your textbook 104. So I can take a look at that also. And there is some options available. The page, I want you to read page 104. There's a number 1 to 9, 15, 18, 19. If you want to stop your process, then use 19. If you want to kill, really kill your process, then you can use number 9. Or if you want to interrupt, what interrupt means is that it performs the same function as the Control-C key sent from the terminal. It usually terminates a program. Remember, some of the programs are interrupted. So you could do, it is like in Windows systems, if you want to kill the process, you usually press Control-C. Similar to that, okay? But in Linux or Unix, if you want to kill the process completely, more strongly, forcefully, then -9 works well. So, for example, if you want to kill this process, then you can say kill number 9, kill -9, and then 5122. That is the process ID. And then if you do PS, then there is no, this one disappeared, and it says killed, that program killed. Okay, I want you to read that and practice a little bit. And then there's the environment. If you environment variable, this is a system variable that runs for you. If you want to see environment variable, then you can do print environment. Okay, then for example, current, if you do pwd, then that is currently working directory is myself. This is for example pwd, and then that's the same as that, right? /home/ju and python, that is this. If we want to do home, then go back to that. These are all the variables. This is mail, path, so all of your path expression is set in this way. So whatever available in this home, jun, bin directory, that is searched and it can be run. In addition to that, .login, if there is a bin directory, it also works. If any command is not available in this path, the next path that your operating system is going to look for is /user usr/local and /bin. And if any command that you issued still not found, then your Linux look for bin. This is a system bin, this is a real simple bin. Another one is USR sbin and USR bin, simply sbin or simply bin, simply user games or user local games or snap.bin. So many binary directory is look for. Okay, if you want to, rather than print all of the system variable, but if you want to print only one of the variables, then you can say echo and then $sign and path. Then you can see all the path expression. Or you can, if you want to see what is my home, because it is defined the home here, so it gives me, oh, your home is /home/jun, for example. Okay. Another thing here is if we want to do echo $PS1, then print string is going to be displayed. Let me see, print string is probably defined here. This is something like something about the print string, prompt string. So prompt string right now is this. What is a prompt string? This is a prompt string. This is something about our. Wait a minute. Yeah, this is @sign. Right now, I have @sign and user, display username, and @sign, and then system name. Actually, that is this, right? Home and work directory. Actually, from here there. That is the print string. if you want either print env, or if you simply say set, then it gives me also all the system variables setting program and variables appears. Okay, displays the shell with the environment variable and functions. A little bit about prompt strings. If we want to look at, then that is somewhere here, the last slide of today's. But let's take a look at that. So for example, in your bash rc, where is the bash rc? That if you type cd, then it goes back to your home directory, and ls minus a, then it runs everything about your the content of your home directory, including hidden files, dot files. One of the hidden file is .bash rc. So if you type, if you want to see what it has, is then you have a bash rc, .bash rc, then it gives you the content of that bash rc. It's a little bit long file. So one of the things that I want to point out, this is a given, right? This is by default. It is given to you. So for example, yeah, PS1, that is defined, right? PS1, and it has user and @sign, and then home and working directory. That is PS1. And if from here, look at this, from here there's if and else, and then phi means this is the beginning of if statements, this is end of that if statements. Okay, so if, and within square bracket, color prompt, if there is a color prompt already set, then use this. If color print is not set, which is else, then use something else, right? In our case, this color is set already, so that you can see the color, right? Then we come back here and do others. So for example, color is not set. Ours is no color, right? So simply this. That is something like this. But if we want to see, for example, we can change this. PS1 equals \e, and I want you to see this, okay? Practice this. And 34m \u, and instead of @sign, if I want to see, for example, star, or I want to do question mark. I mean exclamation mark means something else. So I want to do, say, $sign, and home and work directory, and then I want to make a double greater than sign or triple greater than sign, and end of that prompt string, enter. See here, I have $. I mean triple greater than sign and user. That is right. It is a set. I changed previously my prompt was Jayun and that. Now my prompt is this, as it is explained. Okay, as an example. But if we want to go back to the original, then you can see source minus RC. Then you can go back. Go back to this. What happens? This. Remember, this is content of this file, right? This file is activated when I log in. So this is, if I don't do anything, this is my prompt. But in the meantime, I changed it using export command. This is my variable PS1, but I export it, means I activate it, so that immediately prompt was changed. And then at this point, oh, I want to take it back. How can I take it back? I may rerun this, or I want to do everything that I initially executed when I first logged in. Then I can say, oh, I want to do .bash rc. But in order to do that, you need to type the command source. So anything, the system variable, if you want to change it, then you can say, this is an export. This is a file that you want to rerun, then you can say source, and then .bash rc. Okay, any the process or jobs or program that you made, if it is a Linux command, so-called Linux shell program, if you want to run that shell program, that file contains a sequence of Linux commands, so that if you want to run the series of Linux command, then you can say source space and then file name. Then this file, like this, contains whole sequence of Linux command that is executed in that order. That is a source. Okay. So let's go back here. How environments are setting. If type that, then initially it checks /etc/profile. Your program, when you first log in, here's the steps. It is going to look for general profile. This profile is applicable to all the users. So look for /etc/profile, and then it look for in your directory tilde, which is your own directory. In your directory, if there is a .bash profile, if I see here .bash, do I have that? I do not have that profile. That's okay. If there is no such file, skip it and find out next. .bash login. Do I have .bash login? I do not have .bash login, but I have .bash logout. So it looks like, oh, this is the program to be executed when I log out, right? If I don't have that, then it look for also simply .profile, to have .profile. So when I look at my home directory, I have here .profile. Then I need to see what is running. If I look at .profile, for example, .profile, then I can see this is everything, right? I have only this and path. So when I see this is if only two ifs, right? If bash version if bash version, if there is no bash version, then include that bash rc, and then here if there is a file called bash rc, then run that bash rc. What is .bash rc? That is the file that we looked at minutes ago, right? .bash rc. That's what we looked at. So if you look at this, then my question is to start up. So what is the file needs to run in order to start? If you see .profile, if you see here, then this is the file that start to run. If you want to go out, log out, then .bash logout will be used. So for example, I have .bash logout. So what is in there? So .bash underscore logout, then only this, right? If shell level equals 1, then if this is executed, and then clear the console. So when I log out, it is clear the console, and then the console is disappeared. That is what it does. Alright. So actually this is a shell program. Whatever you see here, dot something, dot bash rc, dot bash logout, or bash something here, a profile. There's a script containing Linux commands. Okay, in a little bit of a programming patterns that you can see, like if, then, else type of things, right? So these shell programs let the system execute Linux commands in certain order, in the order it is written in that file. Okay. For example, if I want to see this file, not the vi is editor, but similar to vi, all the command that we use vi will be used in view view, but view does not modify your program, but we can see it using the command that we use. So if I enter this, then I can see this is a case, right? Case, and then this end of case, so that instead of CASE, we have ESASE. We don't look at this right now, but it's a sequence of the command, right? We define some of the variables. History size 1000, history file size 2000, some of the executions, another case, and prompt string that we looked at minutes ago, right? And also another if statements, and some alias is defined. If we want to see ls uppercase A, then simply instead of type this, you can say simply LA, right? If there is a bash alias file exists, then run that bash alias so that all alias defined will be available as you do. Okay. So for example, if I do LA, then it runs in this way. It's like ls minus a, uppercase L, uppercase A. This is the same as LA, right? Because in that .bash rc file defines the alias. So instead of this, I can, by typing this is the same as that command. So all such things described in that shell file. Okay, so as a starter file, there's more direct. This is a I explained here. This means .bash file. If .bash file exists in the home directory, run it, and then this is add in order to add working directory to path. If there is a home/bin, then add bin directory into the path. If I do not have this bin directory, you do not need to. So for example, here I do not have a bin directory, so it is not necessarily into that path expression. And then I have the PS1, the prompt strings. If you see the prompt strings, for example, like this, 0:34 M. Look at this. I explained here. Say backslash E. Yeah, backslash E and open square bracket indicates the beginning of the color prompt. So this is beginning of the color prompt. So from here, there is a beginning of the color prompt, and then from here to there is ending of the color prompt. Everything inside this as is. So the prompt as we looked at previously, right? Somewhere, remember that we did triple greater than sign as a prompt. That disappeared. So that appears as is. This appears as is. This is a working directory, and this is host, and this works as is. This is a user, and this is the color 0:34 M. 34 semicolon, no, 0:34 semicolon means some color here, blue. That means blue. So all the color code is also available in your textbook. Okay, so I want you to find out. The pattern to set the color is this: X, whatever the number, one number, semicolon, another number, ending with M. As I said here, that is this. Right? If we have, for example, blue, then 0, semicolon, 34, and then M. Then you can have blue color-coded prompt. A little bit detailed. Okay. Okay. Lastly, homework assignment 3. I wanted to do the process, create process, and practice VI editor. Refer to text 123 and 133. Use the VI editor and VI editor to edit a file. File name is my uppercase VI uppercase T test.txt. But push this VI editor to a background process. Okay, and then I want you to show your VI that command is running as a background, running as a background. Okay, see if it is running as a background. I already explained that, right? And bring the background process to foreground. There is a way that you can do that, right? And each steps I wanted to, or the sequence of the steps, if it appears in your entire windows like this, then you can get the screenshot of that as an evidence of your work. See here, screenshot, a few steps above. You may use one screenshot or multiple screenshots. It is up to you. And finally, edit to finish as guided in the textbook. If you see the textbook, and textbook explains open up and for example, what you can do is, according to this, VI my uppercase VI at test.txt, and go back to your textbook, page number 127 up, and that there is, it says you need to insert, so press I button so that you have this dash insert dash, the indicator appears the lower left corner of your windows. There you can type, for example, the quick right, and then type what it says. If we wanted to add, you save it, right? So if you type done, then you can do escape button, then that indicator disappeared. If you want to exit this from this file, then make sure that lower left corner there is no insert mode. If there is insert mode, you need to press escape button. Escape button can be found from your keyboard. So upper left corner, usually there is a button called the ESC. That is the escape button. So press the escape button multiple times. The pressing of the escape button it doesn't hurt, but you can hear some beep like this. That's okay. And then press uppercase ZZ, two zebras, ZZ, then it exits from that editor. So if you type, then you can see that file, my pi text.txt. If you want to go back to edit again, then pi my that file name, enter, then you can see that, right? And go back to that file of the textbook. It says at the end of that line, another sentence needs to be inserted. Right now your cursor is there, right? Anywhere here, if you want to add to the end of that line, then currently there is no insert mode appears here, right? So the keyboard is whatever you type here, keyboard, that is not the keyboard to display as text, but the keyboard is a command. Keyboard, pressing keyboard itself is another command within VI editor. So if I want to move this cursor to the end and continue to edit, then you can do Shift A, which means uppercase A. Press Shift and A, then it goes to the end. It jumps to the end of that line, and automatically it turns to the edit mode, insert mode. So I can keep type. It was cool, right? If you want to stop editing, then anywhere there is a cursor, it doesn't matter, and then press escape button, then this indicator will disappear. Watch, disappear. One more time, escape button, beep. That's fine. And then you can continue to add. If you want to add again, then right there, this is a cursor. Make sure the cursor there, and then press I. If you press I button, then that is a control character. Why? Because there is no insert mode. We are not at the insert editing mode, but any button on your keyboard that could be a control button. So right now, by pressing I, then I want to turn back to edit mode of your VI editor. So press I. Okay, that is insert. I for insert. It can be inserted from this time while insert mode is on. Then I can type whatever I type. Then that is that whatever I press the button on my keyboard, that is text editing. So right here I can do line 2, press enter, line 3, press enter, line 4, line or 5, like that. If you want to stop editing, then which button that I need to press, so that this insert mode will turn back to the control mode. That is press button, press escape button, escape. Do you want me to add press one more escape button? Sure. You can hear the beep, right? One more time. Yeah, not a problem. Because this is not insert mode, so you can move cursor to move your mouse, your cursor anywhere, right? That is possible. All the command, the buttons to move cursors, something like a command a button, then you can read from the manual. If you're done, then make sure that your file is not insert mode. But I want you to have a habit of press escape button as many times as you want before you save and exit from this VI editor. So that one more time, and then I would do Shift to ZZ. Then I can out from my VI mode. If I want to see the manual of VI, then man VI, and press spacebar so that I can have everything about that, right? Okay. All right. This is it for today, and also this is the homework assignments, and your midterm will cover up to this point, this slide. All right, and as I said, let me bring up see here in your this is your Blackboard. If you press announcement, then you can see this announcement. So midterm on Friday 28, 29, and 30. I want you to come, I want you to pick up any one of these time slot, only one. And then you can come to, for example, if you want to take the midterm exam Saturday, October 29th in the evening, 7 p.m., then come in this Blackboard and press course material and midterm. So course material, and somewhere here it's not available right now, but you could see midterm. Probably I may put that on top or to the end, but make sure that there is a you won't miss if you come, right? Midterm. This is called midterm. Then press the midterm, and from there you can take your exam, and once you start, then you have to finish. Okay. And there's only one time permitted. There's no second option. All right. Good luck.